All right, hello, chemistry class. Excuse me. This is Coach Jeans, and today in this video we're going to talk about our single replacement reaction. So in the last video we looked at the 5 different types of reactions that I want you to be able to identify, and one of those reactions is called a single replacement reaction. Now, what I want you to be able to do is, first of all, when you see a single replacement reaction, be able to predict the products that would form if that reaction occurs. And so remember the dance analogy for a single replacement reaction. In a single replacement reaction, a single element will replace another element in the compound, and it will always form a new compound plus another single element. Now, the question that we have to ask is which metal will replace the other metal in the compound? And so it kind of works like this. If you look, you'll have an activity series that I'll give you a copy of this in class, and you'll be able to put this into your notebook. And the elements that are at the top of the activity series, like lithium, rubidium, and potassium, calcium, and so forth, those are the most active metals. And as you work your way down towards lead and copper, silver, platinum, and gold, these are the metals that are least reactive. And so metals will only be able to replace another metal if they're more active. So if they're higher up on the chart, then they will replace the metal that is in the compound. If the metal that is trying to, or the single element is trying to replace the other element, if it's lower on the chart, then it will not replace it. So the dance analogy kind of goes like this. Which guy is more attractive? Elements that are at the top of the activity series are more attractive than elements at the bottom of the activity series. So something like lithium would be more attractive than gold. You say, well, I'd like gold better. Yeah, well, I know, but in terms of chemistry, gold is a very unreactive element, and so it doesn't form many compounds. And so lithium would be able to replace gold, but gold could not replace lithium in the compound. So when we do these types of reactions, we must refer to an activity series like this one. Here's one that I also use, and I'll probably give you a copy of this one in class rather than the other one that showed on the previous slide. But it's the same thing. And lithium, again, is here up at the top, and gold and platinum down here at the bottom. And this one also shows you the most common ion that's formed. So, for example, zinc, when zinc bonds, it most of the time will form, or will always form, a 2 positive ion. Iron, remember, sometimes can be positive 3, but if I don't tell you specifically, use the 2 plus like it is on this chart here. All right, so we're going to take a look at several examples here. So you'll want to copy these examples down in your notes as we go through them together here today. All right. All right, so you'll want to have your activity series chart out that I gave you in class, or you'll want to print off a copy from that previous slide and cut it out and put it into your notebook. So we're going to take a look at several examples here of single replacement reactions, and we're going to try to learn how we can predict these products. So, for example, I would give you the first part, magnesium plus aluminum chloride, okay? And, of course, that needs a 3 on it. Then what I would say is, okay, predict the products of this reaction. What you first need to do is get your activity series, and you need to check your elements on your activity series. And you need to say, okay, where's magnesium? Well, magnesium is located right here. Where's aluminum? Aluminum is directly underneath it. So magnesium is more reactive than aluminum. The elements that are at the top are more reactive. So therefore, magnesium will be able to replace aluminum in the reaction. So magnesium is going to kick out aluminum. So over here, we want to jot the charges down. So we put the symbols along with the charge. Magnesium is a 2 plus charge, okay? And so it's going to bond with chlorine or chloride, and so that's going to be a 1 negative charge. So it's going to take 2 chloride. So we're going to write MgCl2, and that'd be your correct formula for magnesium chloride. And then what's going to be the other product? The other product is going to be the aluminum metal. And when it's aluminum metal, you don't need a subscript or anything like that. All right, this thing needs to be balanced. We always need to balance our chemical equations now. So we see here we've got 1 magnesium, 1 aluminum, but 3 chlorines, and we have 2 over here. So we need to find the least common multiple. So 3 times 2 is 6, and 2 times 3 is 6. So now that changed our chlorines to 6 and 6. Our aluminum is now 2, so we need a 2 right there. Our magnesium is 3, so we need a 3 in front of that one. All right, let's do another one. Let's do zinc metal. Let's go ahead and put our state symbols in here too. Since it's a metal, this one's a solid, and this would be in solution. This would be aqueous. This one would be aqueous, and this one would be a solid. All right, so let's go ahead and put those state symbols in there. All right, let's say we had zinc metal, that would be a solid, plus a solution of hydrochloric acid, HCl, so that's aqueous since it's a solution. All right, we need to see, will this reaction happen? So again, it's a single element, so we think single replacement reaction. We look on our activity series, okay? And we need to say, okay, zinc. Zinc is right here. It's trying to replace hydrogen. Hydrogen is right here. So zinc is higher up. It's more reactive. It will be able to replace hydrogen. So zinc, Zn, it's going to be a 2+ charge, and it's going to bond with chloride, 1 negative. So that's going to be ZnCl2 plus what? Hydrogen, and hydrogen is a diatomic, so it needs to have the H on it. Hydrogen is going to be a gas, and this is going to be in solution, so it's going to be AQ for that one. All right, now let's take a look at another one. Let's say nickel solid, nickel metal, plus chromium nitrate solution. Okay, chromium nitrate, chromium 2 nitrate to be specific on that one. All right. Let's take a look at our activity series, and what we need to find out is, will nickel be able to replace chromium? All right, so we take a look at that. Nickel is where on your activity series? It's located right here. All right, it's located here, and then chromium's above it. So nickel is trying to replace chromium, but nickel is not able to do that. Nickel is less active. So therefore, since nickel is less active, it's lower on our table, then we're simply going to write no reaction, all right? Or you could just substitute NR, no reaction. And therefore, that's all you have to do. You don't need to worry about balancing that one or anything else. All right, let's try another one. Let's say copper metal, so it's a solid, plus aqueous silver nitrate. It's a solution. All right, so we're going to check this one, copper and silver. All right, so copper is located here, and silver is right underneath it. So copper is more active, so therefore it can replace silver. All right, so copper is going to be Cu, and according to our table, copper, we're going to say most of the time is going to be a 2+, so we'll just use that. It's going to bond with nitrate. Nitrate is 1 negative, and so we're going to have CuNO3, all right, plus what? Silver metal, Ag, and so that's going to be your solid, and that's going to be your aqueous solution. Okay, so that's how this is done using symbols, using formulas. Now, let's take a look at examples with words. So you want to jot this down, examples with words. So we're going to go with word equations here. All right, the first example we'll say is metallic iron is dropped into a solution of copper 2 chloride. It's supposed to be copper 2 chloride. All right, so you see this in words, and remember what we have to do is we have to convert this over to symbols. So we have iron and we have copper 2 chloride. So the symbol for iron is Fe, it's metallic, so that means it's a solid, plus copper 2 chloride, excuse me. So we have Cu, it's copper 2, so it's 2+, chlorine is 1 negative, so it's going to be CuCl2. It's a solution, so we're going to put the symbol aqueous. All right, then we go to check our activity series again, and we need to find iron and copper. All right, so iron is located here, and copper's underneath it here. So iron is able to replace copper. So iron, we're going to use the 2+. And you say, well, where'd that come from? Well, go back to the chart that I gave you. Iron, we're going to use the 2+. Now, it could be a 2 or a 3+ if it was iron 3, but since I didn't tell you specifically, just use the 2+. So it's going to bond with your chlorine, which is 1 negative, chloride, and so that's going to be FeCl2, and then copper metal, Cu, and it is a solid, and this one is an aqueous solution as well. All right, so we need to make sure that it is balanced, and I think it is. Okay. Actually, yeah, it is. It sure is. One iron, one copper, two chlorides, two chlorides. So it is okay. It's balanced. All right, let's do another one with words. All right, this one is magnesium metal is placed into a concentrated solution of hydrochloric acid. All right. Magnesium metal is placed into a concentrated solution of hydrochloric acid. Sorry about that. You might want to pause it and go ahead and copy that down. All right. Magnesium metal is placed into a concentrated solution of hydrochloric acid. All right. So we're going to have magnesium, Mg. It's a solid because it's a metal. It's placed into, so it's going to react with hydrochloric acid. So hydrochloric acid, we have H plus. And remember, if it's hydroic, that means it's a chloride, IDE ending on it. So that's one negative. So that gives us HCl. Okay. We look at our activity series, and we have magnesium up here. We have hydrogen down here. So magnesium, here it is. Magnesium is up here. Hydrogen is down here. So magnesium will be able to replace hydrogen. So again, we have magnesium. It's a 2 plus. It's going to bond with chloride. So we form magnesium chloride, MgCl2, plus hydrogen gas, H2. All right. And so we need to make sure we put our state symbols on this. Okay, this is aqueous on this one. This one's aqueous because it is a solution. Now we need to make sure that it is balanced. And so we need to have a 2 placed right here. And that'll take care of our hydrogen, and that'll take care of our chlorine. We have one magnesium and one magnesium. So that's it. And we'll work some more examples of this in class and go over any questions that you might have and give you an opportunity to practice some worksheets. Okay, I'll see you in class.